my affectionate Dr. Srinivasan, Head of the Department of Education, and dear students. It is my pleasure and privilege to be with you and to just talk and discuss about the how to solve the mathematical problems, how to teach the students, and to how they can just solve the problems. See, the students, it is not that they don't know mathematics. They only lack the technicalities or the mechanism of how to solve the problems. If we can channelize the methods, how to solve the problems, they will be in a position to solve the problems easily, understand the problems. See, what I am going to do right now is that I am going to give you a simple software like that, which you can follow and you can teach the students to just follow that software. It is not exactly software, we are trying to just give the program so that will be just introduced and implemented and in the brain. See, when you take up a problem or when you look at the problem, how do you go about it? So just let me take an example and then I proceed. See, the most important thing because you are going to generate the new generation. So your work is the most important thing. And unless you enjoy teaching, the students will not enjoy learning. Now let me take up a simple problem and then we will just proceed and then I will give you the ideas how to just solve the problem, what are the implements that you have to introduce there. See, this is the problem. A point on the hypotenuse of a right-angled triangle is at a distance A and B from the sides of the triangle. Show that the minimum length of the hypotenuse is A power 2 by 3 plus B power 2 by 3, power 3 by 2. I want to explain the whole concept completely, taking up a simple problem. Suppose if I don't take a problem and if I don't explain that way, it is like how to, just when I want to teach you how to swim, you cannot do it on a bed or something like that, you have to go to the swimming pool and do it. Same thing. Now let me explain the whole concept by taking up a problem. A point on the hypotenuse of a right angled triangle is at a distance A and B from the sides of a triangle. Show that the minimum length of the hypotenuse is A power 2 by 3 plus B power 2 by 3 power 3 by 2. Now, the first foremost thing that is required is the understanding the problem. First of all, the students must understand the problem. Then, next thing you have to ask the students, what is unknown? See, or you can ask the same thing, that is what is unknown, in different manners also. That is what we are seeking and what is to be found out. That way also you can just teach the same thing. Then the next thing, that is the first thing is unknown. Then next thing you should ask the students, what are the given data? That is given data or information, I can say even that one. See, in this problem, what is unknown, they must be able to just tell you what is unknown. That is the important thing. It is not simply you just go on to the next step. So the unknown is the length of the hypotenuse. It is not only, next thing you must ask them, is it only the length of the hypotenuse? Then what is the word, this thing, minimum? So they must be able to understand that and they are going to just find out, and the unknown is the minimum length of the hypotenuse. That is how they should understand. So what is to be found out is to be very clear cut. That is the minimum length of the hypotenuse. Then, actually they are supposed to prove this, that is equal to this much. Then what is the given data, that our information or what we know? Because to reach the unknown, we must just start from the known to the unknown. So what is the data? What are the informations provided there? So here they given that if you see the look at thing, say it is a right angled triangle first of all, and then you have to find, that is the another thing unknown is the hypotenuse, the length. It is not something else. So you have to find the minimum length of the hypotenuse, this one, and it's a right angle triangle, and there is a point on the hypotenuse which is at a distance of A and B from the two sides. Now you should, when you see a problem, you should think whether we have done already a problem something similar to this thing, or at least analogous to this thing, or this unknown also. Have we done a problem which is where the question is that the unknown has been asked which is similar to this thing, or it is the exact same thing or analogous to this thing. But if you have not done any problem similar to this thing, because one thing I want to tell you students, when you take up any mathematics book, see, when you take up any exercise, if you see the examples and the exercise, the examples will be the examples and the questions asked in the exercise, there will be a correlation. And not only that thing, in the exercise also, suppose 25 problems are there, suppose 25 problems, you can just group them into 5 sets. It is not all the 25 problems are entirely different from each other. No, not at all, not at all, not at all. Suppose if that is the case, if the 1500 problems are in the book, then what will happen? Is it the 1500 problems are entirely different from each other? No. They have got something common, they can be grouped together. That I will come to that thing afterwards, this thing. So this is the unknown. Now you use the notations. So that is, I explained this, A and B is known, so that I will write it. So given data, a point on the hypotenuse and which is at a distances A and B from the sides. 3 sides and 1 is the hypotenuse, only there are 2 sides left. So A and B from the sides. Now come to this thing. Do you need a diagram or not? Yes, because without the diagram you will not be able to just complete the problem, or you will not be able to solve it at all. So, and not only that, a point is given on the hypotenuse and it's a right angle triangle and the distance is A and B. So naturally it needs a diagram. So you should for every problem you should ask all these things the students. So there is a diagram. See this thing. So I take a point here P. Now this is your ABC is a right angled triangle, and this is the point. This distance I take it as B, and this distance I take it as A. Now what is the thing? See, it is given that from the point B to this side AB the distance is B, and from the point P the distance to this thing is side is A. Now the required thing is that minimum length of this BC is this much. You will be wondering, and some student may get up and ask you that, sir, when the A and B are constants, is it not BC is going to be constant? Naturally, any student will ask it. Now it is for you to explain it is not so. And not only that, you can take a room itself, your own classroom, and explain to them it is not so, because the diagonal is this thing from there to that end. And now see what happens. From you can take any point on the diagonal and drop it on the line here. This distance and this distance will be A and B. But here what happens, I want to express this thing is that, see, A and B are constant, but the length of AB and length of AC are not given. That is the most important, because this thing, suppose I take this line, suppose I just fix the point B here, then what happens? This distance is not changed, this distance is not changed, but still what happens? The hypotenuse goes from there, that's the thing, and it may be length may be more or less. It can be make it as a maximum also, because I can just draw it here, I can draw it here, and then like this I can fix it also. What happens? See this thing? Now what happens? Here I can just produce AB up to this thing. So your hypotenuse is now it has become maximum, isn't it? So now this is for you to explain to them. It is not so. That is so, but it can be done. But the point P can be anywhere. That is also there on the, it is not given. Only thing is that the distance is B and distance is A. Now comes the other part. Now minimum length of the hypotenuse. What concepts you can use? What is the thing required concept here? So we just go to differentiation. In differentiation, maximum minimum. Because now, so here there is no variable at all. Then where is the variable comes? Differentiation means rate of change. One quantity varies with respect to another thing. So or one variable with respect to another variable. Now we are introducing this theta. See this thing. Now theta is the variable. Now what happens? I cannot take this as the hypotenuse. See this thing. Because theta I am just putting a variable. So the theta varies in such a way that the length of BC, the length of the hypotenuse becomes minimum. So now let me try to solve the problem and explain also to you. Now when this is theta, this is also theta. Either you say corresponding angles. See, a simple concept can be just explained in other ways also. Now you can tell them this is 90 minus theta, the whole thing is 180, this is 90 and this thing. See, there is another way also. Now don't you feel this, then your drawings. Now I draw the perpendicular PM and here I draw the PL. So your PM is B and PL is A. See what happens, you can explain to them also. See you can take a rectangle here. What I am trying to tell you is that your variable comes into the picture. How it comes? See, the students will be just baffled. So this is your P. So you can have a hypotenuse like this. You can have a hypotenuse like this. You can have a hypotenuse like this. Isn't it? See, this is the thing. What happens? These lengths of the sides differ because the theta, I take different thetas. Now you are going to find theta in such a way that the hypotenuse, the length of the hypotenuse BC is going to be minimum. This you have to explain to the students. This is where normally they get confused. Think as though you are a student sitting in a class and listening to a lecturer. That is the most important thing. Because after finishing a degree and all these things, you are well equipped and you know more subject than the student. And you have to step into his shoe and see how he can learn things. So now I introduce theta. So now you have to ask them why I introduce theta and what is the connection between theta, A, B and BC. Now that is why I just drew the diagram of the rectangle and I showed all these things. Theta varies. But when theta varies, what happens? The length of BC or the length of the hypotenuse is changing according to theta. Now he has given a very categorically just given this thing, the minimum length of the hypotenuse. So when the length of the hypotenuse BC becomes minimum depending on theta. So the length of theta and the angle of theta, the value of the theta and the length BC, they are related to each other. Now we will just take up this thing. So now we introduce the notation. What is the notation? Now you have to go this way only. First you say understanding of the problem, then the unknown, and ask them whether they have done similar problems already and whether have done any problem similar to this thing where the unknown and this unknown are exactly same, or they are not same but still analogous this thing, then you just draw the diagram is required, then you draw the diagram, and then what is required, and see, this theta is not mentioned in the problem at all. Then you have to explain to them how the theta comes into play. That is where the whole crux of the whole problem is lying here. Otherwise, they will be wondering how this theta comes, why this thing, when A and B are constant, BC, the length of the hypotenuse must be constant, what is this thing? They will be wondering. So then you have to explain how this thing this A and B, even though fixed thing, this length of the hypotenuse can vary. But we want the minimum length of the hypotenuse in such a way that theta gives or related to that thing. Now let me, notations I am coming. Now let me take BC equal to some x. Say the hypotenuse equal to x, this is the variable. Now what is your BC? BC equal to, or x equal to BC, and this is equal to PC plus PB. Now you should ask him, see PC, how can I just get the length of PC? You should ask them. Then they must be able to understand that this is also a right angle triangle. From this right angle triangle, your adjacent side is known. Your hypotenuse is nothing but BC. You explain to them and ask them, get their answers from them. You have to kindle the fire. It will take some time. But it is like, you may be wondering, sir, do I have such an amount of time in the class? See, it is like just teaching them how to ride a cycle. In the beginning, he may just fall down. He may have little bit of scratches here and there. Then what happens? Slowly, then he will have fear also. When he falls on the ground, then he will have scratches here and there. Some blood will be oozing out and all these things. He will have some fear. Naturally, no doubt about at all. But what happens after some time, the fellow himself, you should make him just to take some interest to ride the bike, a cycle. Then after some time what happens, he will enjoy just riding the cycle. Then what happens, he will go off his own. Same thing here. When you just adopt these type of methods and then teach them, it is a time consuming process, no doubt at all. But what happens, you are kindling the fire in them. And you are just trying to bring out the ideas, because he is already having the ideas. You are channelizing the ideas, that is the thing. You are creating an interest in the subject. So that takes time. But what happens after doing a few problems, then he will be able to do similar problems like this, and then slightly different problems like this thing, and he will try to enjoy just like as he is riding the cycle and happily there this thing. So this x equal to PC plus PB. Now you should ask them, how can I calculate PC? Now because A is known, theta is introduced, so he will tell you, sir, in this right angle triangle, this is adjacent side by hypotenuse, that is A by, what is that? Adjacent of PC equal to your cos theta. So your PC equal to A by cos theta, that is A secant theta. And then again you ask him, can you calculate PB? Same, one of the students will be able to just tell you, but he will not go to cos theta. You can tell them, you can just kindle this thing interest. See, here it is opposite side, there it is the adjacent side. Here opposite side and then hypotenuse, what type of trigonometry ratio you will use it? Then he will be, naturally, all the students will tell you, that is your sin theta, that is equal to B by PB, or your PB equal to B by sin theta, that is equal to B cosecant theta. Okay? Now comes your this thing. Just I'll wipe it off that.